everyone, let's get started because for what seems like not everyone is going to join. So it is what it is. Hold on, I'm gonna mute Leopold real quick. So yeah, let's get started. Everyone, so today what I want to do is I want to go over the notes that I gave you guys for Tuesday and for today. I just want to talk briefly about gas laws, okay? And what I'll do is I'll just upload this PowerPoint on the hub for those who missed it or want to come back to it at the end, okay? And so I'm going to allow you guys to unmute yourselves. You can ask questions, but basically this is gonna be it. It's gonna be 18 of us. It'll be a small class. It is what it is. And yeah, I'll just try to make this short and brief, okay? And so everyone, today's lesson is gonna be over Boyle's and Charles's law. These are two of the four gas laws that we're gonna cover over the next 3 weeks, okay? So we're taking this really, really slow. And so let's get to it. All right. So my PowerPoint didn't change at all. Awkward. There we go. All right, so everyone, I briefly want to review your states of matter, okay? So we have solids, liquids, and we have gases, okay? We took notes over the states of matter at the beginning of the school year, all right? So you guys know solids, they hold a shape and they have a fixed volume. Remember guys, volume is how much space something takes up. A small cube has a small volume, a bigger cube takes up more space. Liquids, all right, are a bit more fluid. They take the surface or take the shape of the container, but their volumes are also going to be fixed as well. And then you have gases, okay? Gases take the shape of the container and also the volume of the container as well. They fill up the room, fill up the balloon, fill up whatever they're being placed in. Now, there's something I'm going to cover next week that you can read about. It's called the kinetic molecular theory, okay? And basically, it talks about how temperature measures the kinetic energy of particles. And I might have mentioned it at the school year here and there about how particles react. But keep this in mind, temperature doesn't just tell you how hot or how cold something is. It tells you how much kinetic energy those particles are going to have. And with that being said, I want to go over, all right, the first law, Boyle's law, okay? So online, I gave you a big PDF to read, okay? Some notes, some historical context, but this is the gist of it, okay? This is Boyle's law right here. Plain and simple. It is your initial pressure multiplied by your initial volume is going to equal your new pressure multiplied by your new volume, okay? Boyle said this, as long as, and hold on, let me annotate this. All right, here we go. And then a text box, okay? So there are parameters to this. Boyle's law says this, condition. This condition has to be kept. And the condition is this, as long as temperature is constant, okay? The pressure and volume are going to share something known as an inverse relationship, or they're going to be indirectly related, okay? So you look over here, guys, on this graph, you see a negative slope, okay? Because why? It's going to be decreasing as you go across pressure, okay? As in, as your pressure increases, okay, it gets bigger and bigger, your volume is going to decrease and vice versa. As your pressure is going to get smaller and smaller and smaller, your volume is going to get bigger, okay? We call this an indirect or inversely proportional relationship. Now, as for the units, again, I gave it to you guys in your notes. Pressure is measured in atmospheres, millimeters of mercury, torr, or kilopascals, all right? Oh, great days here, all right? Hey, great day, sorry about that. My eyes were on the big screen, okay? So these are all listed on your notes. Just simply turn to it for reference. Now, volume, you guys actually do know. Volume is going to be in, oh, where's the mouse at? Oh, it's embarrassing. I can't find a mouse right now. This is weird. Anyway, volume is going to be in millimeters or in liters, okay? So now, that's pretty simple, okay? Now the hard part is going to be actually solving for this because I gave you guys some math problems to work on. Wow, people are joining in. Sorry, give me 1 second. Where's my mouse at? There's a mouse. Okay, here we go. All right. Yeah. So, all right. I guess so far, are there any questions, or are we all good to move on? By the way, y'all can unmute yourselves if you want to. Y'all good? Any questions?
Adriana.
Yeah,
Oh
a
my
question.
gosh. Never mind. All right, I'm gonna mute you guys again. All right, moving on. So I'm just gonna move on. Okay, moving on. Now, this is the part that I actually want to work on. Okay, so everyone. All right, so I actually want to do some math problems with you guys because guess what? With gas laws, we have to work on problems. So this is the problem that I put in your reading, but some of you guys may have struggled to figure out how the math works, okay? And so, hold on 1 second here. I am scared to click this, but instead I will. Oh, children. Anywho, so back to this, okay? And so, example 1, okay? This is from the reading that I gave you guys to work on, okay? This is the problem that I worked out for you guys, but I'm doing it again because now everyone understands how to solve this problem when I just type it out. So, this is what you should expect for gas law problem, okay? We have a gas in a 2.5 liter container with pressure of 1.7 atmospheres, okay? The question is asking this: if the gas is transferred over to a small container with a volume of 2 liters, the question is asking what is our new pressure going to be, okay? And so guys, I've taught you how to solve problems before, and so it's going to be the same steps as always, okay? So step 1, guys, I always have you guys do what? Write out your formula. Our formula is going to be P1 multiplied by V1 is going to equal what? P2 multiplied by V2, okay? That's the formula that we just went over on the first slide, okay? Now, the next part is to identify what our variables are going to be or what our values are, okay? And so we have 4 variables to deal with, okay? So the first one, if I can find my mouse real quick. There we go, Control Z. So the first one's going to be, this is weird. Why the mouse always gone? Give me a second, guys. Trying to figure out how to work this thing. All right, so there we go. So we're gonna have what? P1, all right. And then we're gonna have V1. And then down here, we're going to have P2. And then down here, we're going to have V2, okay? So we need to identify what each of these variables are and what their values are going to be. And so right here, guys, okay, we have 2.5 liters, okay? I think most of you guys know that liters means volume. So this is going to be our V1. And so for here, for V1, we're gonna write, we have 2.5 liters. For P1, it's going to be over here, which is 1.7 atmospheres, okay? So you have to use that table I gave you guys, or the notes I gave you guys, to know what your units are for pressure. Because pressure can be atmospheres, kilopascals, millimeters of mercury, or torr. Now, what do we know now, okay? So over here, we have that it says the new container has a volume of what? 2 liters. And so for V2 is going to be what? Simply 2.0 liters. Let me make it a little prettier because it's hard to write on this thing. Okay, so we have what? As V2 is going to be 2.0 liters, all right? And so for the second pressure, we're trying to figure out. That's what our question is asking. What is the new pressure in our new container? And so that's going to be our unknown. And so now that we identified what we have real quick, P1 was simply 1.7 ATM. All right, we're not going to solve for P2. So over here, what do we do now? We're going to simply plug in our numbers, okay? So we have now P1 is 1.7, so we have 1.7, okay? It's going to be multiplied by what? 2.5 is going to be set equal to, we don't know what P2 is, that will be our unknown, and so we're going to write P2 multiplied by, we do know what V2 is. V2 is going to be simply 2, okay? So we're trying to solve for our unknown, which is what, guys? P2. And so what do we do? All right, we first multiply 1.7 times 2.5. So real quick, that should be easy. Not working. Okay, so you do 1.7 times 2.5, which should give you guys 4.25. Okay, so let me find my mouse again. So we have what? We have as our answer 4, hold up, that was bad. So we're going to have 4.25. It's really hard to write 5 on this thing. Equals, all right, we simply now have P2 multiplied times 2, okay? We have 4.25 equals P2 times 2. The next step is to cancel out the 2. And so, guys, to cancel the 2, we're going to divide each side by 2. Because guess what? The 2's are now going to cancel out. And over here, we're going to have 4.25 divided by 2. And so with that being said, it's going to be P2 equals 4.25 over 2, which is simply going to give you guys 2.1, oh gosh, 125. Let me do a little better. To 5, okay? And so, and then your units, okay, for pressure, simply use what was listed in the problem, which was in this case atmosphere. So it would be 1.125 ATM for atmospheres. All right, so any questions so far, guys? America, you good?
No, it's pretty easy.
All right, I hope it is, y'all. I really hope it is. Because this is what we're gonna do for the next 3 weeks, guys. Like literally, it's just gonna be doing these types of problems, and this will be the hardest one. Like this is hard as it gets, guys. You solve for the unknown. So, yeah.
Okay, we do this. We do this every time in geometry.
Hey, that's good to know. I'm glad y'all get this. Okay, and so
turn on the chat. That's the only thing that's keeping us sane.
Christian, you will live.
Hello.
Mister, is the school open?
Chat on.
No, school's open. Actually, no. I heard they will open it, so you can go get your stuff if you need it. So yeah.
Huh? So now it isn't?
Bored.
Ventura,
Yes, ma'am.
Will we ever go over bases and asks again?
Because I missed that whole week due to personal stuff, unfortunately, we had to kind of cut S's and bases. So yeah, like y'all, unfortunately, y'all just
Oh my
for
god.
so for pre-AP, basically, y'all got more than notes because on level I didn't get a chance to go over more notes, and so basically, yeah, that's all we did for S's and bases. We weren't able to do a lab. Cause it kind of sucks because like here, let me you guys real quick. Because guys, remember, the point like so basically April was our last month of actual chemistry, and then May was the fun stuff, which was ice cream and doing like the tie-dye t-shirts. But at the rate things are going right now, guys, it is quite possible we might not get to do the ice cream or the tie-dye shirt or all the cool projects that we have for the end of the school year. So yeah, it kind of sucks, unfortunately, that we're doing this at home because we get the fun stuff
You're
like
not going back to school, Mr. V. You might as well forget about it.
yeah. So anywho. All right. So everyone, let's move on. I want to do.
Bye.
All right. So anyway, I want to do one more problem because you guys know me so well that I love doing 2 example problems. Okay. As Kevin said, it's just like geometry. So I'm hopeful that it should be pretty straightforward. And so everyone, this problem reads like this. Okay. We have a gas in a 1.5 liter container. All right. And so has a pressure of 0.7 atmospheres. So the question is this: if it's moved to a big container, all right, the question is asking what will the new pressure of the gas be? Now, let me go back to this part right here, okay? I told you guys that these 2 variables have an indirect relationship, meaning, all right, if P if P were to increase, V would decrease and vice versa, okay? If P decreases, then V would also increase as well, okay? What happens to one, the other gets the opposite of. So when it comes to these problems, you can always figure out, all right, if my pressure is going to increase, therefore my volume is also going to decrease as well, okay? So keep that in mind. All right, so let's go back to this last problem that I had up real quick. All right, so over here we have this problem, all right? 1.5 is going to be our volume, okay? Because volume is measured in liters. Atmospheres is one of the common units used to describe pressure, all right? And it says here, all right, if the gas is moved to a bigger container, which in this case, okay, this is V1, this is V2, all right? We're trying to find our new pressure. So this is P1. This is going to be P2. Okay? So real quick, let's solve this problem on the spot. So your formula, guys, as you know, is going to be P. Oh gosh, that was bad. It's going to be. There we go. It's going to be P1. All right, multiplied by. Where's it? There we go. V1 equals what? It's going to be P2 multiplied by V2, right? And so we've already identified our variables here. All right, so P1 is going to be 1.5. We're going to multiply it by, all right, V1, which is over here. It's going to be 0.7. And so we write 0.7. It's set equal to, all right? We don't know P2, so we're just going to write P2 multiplied by V2, which in this case we know to be what? 4. And so all we're doing is 1.5 times 0.7 on this side. So real quick on a calculator, on your phone, whichever is easier. All right. So 1.5 times 0.7 is going to simply give you guys 1.0605 is going to equal, there you go, P2 times 4. The last step, guys, all right, like the last problem, divide each side by 4. So we divide each side by 4 because why? The 4s are going to cancel out. So we have 1.05 over 4. And that will give us our answer, which is going to be, we have P2 is going to equal, real quick on the calculator, you do it. And we'll simply give you an answer. We'll just stick with 0.26. And because it's pressure, we'll use atmosphere, which is used in the problem as well. And so our answer is 0.26 ATM for atmospheres. All right. Here's Galaxy 9. And all right. Any questions so far, guys?
No.
No.
You do.
All right.
When we done?
What time do TikTok with me? TikTok with me.
What was the question? Who said what time we're gonna be done?
Yes.
what time?
Honestly, guys, I've like.
Mr. Ventura, I have a question.
What's up?
Does grades come for the whole cycle on Friday, or that's just the deadline?
Let me get all this. So, Ralasia asked real quick. So I'm gonna you guys. Ralasia asked when our grades due. So listen, I've already pulled the grades in. I think for the most part, like everyone who's in this group chat is passing the class, and your grades are in pretty good standing. I do need to double check though if you haven't submitted that molarity problem set on the hub. But besides that, yeah, I'm done with grades. It's only 10 grades. Your teachers do have an extra week to submit grades because it's kind of awkward right now. But yeah, for the most part, like your grades are due by next Friday. So, Elijah, is that
They
answer your
said
question?
April 3rd.
No, they give
They
us.
said this Friday.
Is this going to be the report card grades?
Yeah, more or less. Yeah. So for my class.
Okay.
Who is banging on pot?
So for my class, what you guys see, all right, is basically what you're gonna have for your 6 weeks. And again, I think for people in this group chat, you're all doing pretty well. So I'm not too worried about you guys. So yeah. All right, we good?
Mr. Ventura.
Ventura, I
Yes,
don't have a
Kristen.
laptop charger.
Kristen, what's your question?
That's messed up. Anyway, cause like, okay, so when we do the work on the hub,
Yeah.
and it says the questions or whatever, it doesn't let me do it.
Really?
That's your fault, bro.
It should be pretty easy. You should be able to submit the questions like normally.
Mr. Ventura, my laptop won't let me get on YouTube.
Mine's
Really?
on
Either watermelon video.
restricted stuff. They got stuff restricted. It can't get on YouTube.
Exactly. So ghetto.
Yeah.
That's
It's,
making me mad.
it
Hey, but
is
the
what
worst
it
one-
is. No.
Who is playing the game? Who is playing the game?
All right. So everyone,
Go
we're almost
tomorrow.
done.
He finna mute us.
Yeah.
Mm-hmm.
All right, so guys, listen, I am trying to finish up the lesson, okay? So we have Charles' Law and 2 more examples, and after that, honestly, we're done. I'm just keeping it short and simple. So everyone, we now have Charles' Law, okay? So Charles' Law is basically in regards to volume and temperature, okay? So there's one parameter that has to be met or be kept in order for this law to keep in place, okay? So for Boyle's law, it was you had to keep temperature constant. For Charles' law, pressure must be constant, meaning pressure is not going to change at all throughout this whole process, okay? Pressure will be constant. And so now, okay? Yes, Kevin, you raised your hand. You good, Kevin?
Yeah. I'm good. I'm good.
All right, cool. All right, so back to this. So everyone, for Charles' law, okay, we're dealing with volume and temperature, okay? It's quite simple, all right? as your temperature gets hotter and hotter and hotter, or goes higher and higher and higher, your volume is going to increase as a result of that, okay? And we call this a direct relationship, meaning, guys, if V, whoops, wrong one. All right, there we go. If V increases, guess what? Temperature will also follow as well. Temperature will also increase as well. And vice versa. If the volume gets smaller, your temperature will also get smaller as well, okay? So keep that in mind, okay? So whatever changes happen to them, okay, it happens to the other variable as well. V gets bigger, T also gets bigger. V gets smaller, T also gets smaller as well. For units, volume will still be in milliliters and liters, but temperature can either be in Kelvin or Celsius, okay? So if you see Kelvin, don't freak out. It's simply a different unit for measuring temperature, all right?
I don't know.
Ventura,
Yes, and Karen,
I don't have a laptop charger.
do you have a personal laptop?
Nobody cares,
No.
Anna Karen.
Nobody.
Nobody cares, Anna Karen.
Stop, Kevin.
What
All
is
right,
it?
I'm gonna continue. All right, so moving on. All right, so moving on now to the example, all right? So everyone, example 3, this is the one I did in your reading, but I'll do it again. So this question is simply asking, okay, at 189 Kelvin, which will be your temperature, all right, a sample of gas has a volume of 32 milliliters, okay? So this is going to be your V1, and over here, this will be your initial temperature, okay? The question is asking what volume will this gas have at this final temperature, which is going to be T2, okay? Is we have to write T's on here, right? So again, the steps are gonna be what, guys? We're going to write out our formula, okay? So your formula is simply, all right, we have V1 divided by T1, okay? So V1 over T1, all right, is going to, okay, be equal to, we now have V2 over T2, okay? Looks ugly, but it is what it is, okay? So we have V1 over T1 equals V2 over T2, right? We've listed out our variables. 189 is T1, 32 is going to be V1, and then over here, our 242 is going to be T2. So real quick, before we move on, I want to make sure we have these down. So our initial temperature is going to be 189 Kelvin, all right? And then our V1 is going to be what? 32 milliliters, all right? T1, our final temperature, guys, is going to simply be, all right, it's going to be 242 milliliters. And then for V2, which is the one we don't know, is going to be our unknown. And so now this are our variables. We're going to plug in our numbers and see what we get as our answer, okay? So now we're going to have over here, V1, all right, is going to be 32. Divided by, all right, 180, 189. And we're going to set that equal to, all right, we don't know V2. So we're simply going to write V2 divided by 242. Okay, so this is our problem. We're trying to solve for V2. Okay, and so what do we do? Well, there's two options. Okay, I'm gonna go with the quick one, which is we're going to cancel out the 242, which is on both sides. And how we do that? We simply multiply each side by 242 because why? What happens? The 242 on top will cancel out the one on the bottom. And so by doing that, these two cancel out. And then on this side, okay, we're going to have 242 times this fraction, which is 32 over 189. So we're going to do some quick math on this side because this is where the meat of the math is going to be, okay? So first, you can do 32 divided by 89, which gives you 0.17. And then you do 0.17 multiplied by 242. And once you get that, guys, that's going to be your answer, which in this case, I got 41. Okay, I got 41. Because it's volume, I'm going to do milliliters, is the value of V2. All right, so.
Oh, Coach Grad don't be doing that.
All right, we good so far, you guys?
Good. Wait, let me screenshot it.
What's up?
I screenshotted it.
Kevin,
Yeah.
Kevin, I missed you.
Did this due tomorrow?
What was that?
I got so much grades due tomorrow. It don't make no sense. I just checked the team.
All right, so everyone,
Okay.
I have one more slide to do, and after that, I am done with my little Zoom call, okay? So everyone,
Okay.
example 4, and
Before you
afterwards,
leave, show your face.
nah. All right, so we're. All right, so. All right, guys. I'll meet you guys one last time, and then we can call it a day. All right, so everyone, the last problem, okay? So a gas has a volume of 4.0 liters and temperature of 45 degrees Celsius. The question is asking, when the volume changes to 9 liters, the question is, what is our new temperature? So this time, guys, we're solving for temperature, which is, oh, my bad. This time we're solving for temperature, all right, which is going to be T2, okay? We're solving for this case, T2. So what do we have in the problem? Our initial volume was 4, so that's going to make it V1. While over here, guys, our initial temperature was 45 degrees Celsius, which makes that T1. We're trying to solve for T2. Over here, the 9.0 liters is going to be our not V1, but V2 indeed. Okay? So, we have our variables. We're now going to solve for them, okay? Our formula, guys, is once again, V1 over T1 is going to equal what? We have V2 over T2. And so we plug in what numbers, or plug in the numbers that we have, okay? So V1 is 4, and so we're going to do what? 4.0 divided by our T1, which is 45 degrees. So we're going to put down here 45 degrees. All right, we set that equal to the other side. On top, we know our V2, it's going to be 9.0, and then we divide by T2, which we are trying to solve for, okay? And so, once again, like the last problem, we're trying to solve for one of our variables, all right? Now, this time, we have T2 on the bottom. And so, two approaches, I'm going to do crisscross multiplication because that is, in my opinion, the easiest way to go with this. So I'm going to crisscross 4 times T2, okay? So that's going to give me, okay, so on this side, I'm going to have this. I now have 4.0 times T2 is equal to, now over here, I have 9.0 times 45, okay? So now I'm going to have what? 9, hold on, change colors real quick. We have 9 times 45, okay? And so like last time, we're trying to solve for T2 or unknown variable. So easy peasy, lemon squeezy, divide each side by 4.0. All right, so down here we have 4, I suck at writing 4s, 4.0. Same over here, we have 4.0. And so the 4s on this side will cancel out. And all we do now is 9 times 45 divided by 4, and that will give us our solution, okay? And so T2 is going to equal whatever it is we get from doing all the math in this fraction here. So we do 9 times 45, which gives you 405, divided by 4, which will give you an answer of 101 point, ooh, that was ugly, 104.25. And your units are going to be in, oopsie daisy, it's going to be in Celsius, so degrees C, okay? Not the prettiest handwriting, but whatever. And so, everyone, that's honestly all I have for today. I just want to go over the 2 laws real quick. I think you understand how they work. With Boyle's law, as pressure changes, volume will be opposite of it. So if pressure increases, volume will decrease, and vice versa. Pressure decreases and volume increases. With Charles' law, they're both directly related, meaning as your volume increases, so does the temperature, okay? I made the little readings for y'all to keep. Seriously, like, all the information you need is in there, okay? I worked out examples on there, and you have all the vocab, formulas, units, and all that you need, okay? And I'll probably just keep uploading readings like that throughout the next 2 or 3 weeks, so you can just, yeah, you can just pull from them and download them or whatever you want to do, okay? So for next week, I'm gonna give you guys like 2 more readings. We'll do Gay-Lussac's law, and we'll also do Avogadro's law. And I'll probably throw in a small reading in there as well over the kinetic what they're doing. So
Are you gonna be on tomorrow too?
I mean, I'll go on my email and on my